All right. So, hello everybody. Now, today is the last session, and we'll be discussing three major things today. One is data validation, the other is data analysis, and graphs. Now, data validation is a very small topic, so it won't take a lot of time. But data analysis is something that will take quite a bit of time. And then, of course, graphs, which is again very straightforward, especially in the newer versions of Excel. It's very easy to make graphs because it gives you suggestions and everything. So if you know what you want to portray, then it becomes very easy to do. Okay. So we'll be starting with data validation. Now, when it comes to data validation, basically you're restricting a user's input to a particular question. Okay. So for example, let's say if this is the data that we have, and we want to add say mobile numbers. Okay. Now, let's say you want to standardize this. So you don't want anybody to write country code or whatever, the state code and everything. You want people to just put their 10-digit mobile numbers. Now, to do that, you will have to make sure that if, let's say, you're sending this to somebody and people are just filling in this Excel sheet, people will always write. For example, in India, people will write whatever, +91, put a hyphen, and then put their mobile number. So somebody will write their mobile number starting with 0. Right? So you want to avoid that. Now to do that, what you can do is you can select the range that you have and do data validation. So I'll just illustrate how you can do that. So let's say this is the range that we have. We'll go to data, and under data we have data validation. Okay, I'll just click on this and it will open a box. Now in this it says settings validation criteria. So what is the validation criteria that we have? So here we are going to say, we are going to put text length. Okay, now text length, we are going to say data equal to, and the length is 10, which means that if anything has more than 10 characters, it will show some error message. It will not allow user to put in more than 10 characters or less than 10 characters. This is because we have put equal to 10. Now, if you, let's say, want, this is some other data, it's not mobile numbers, if it is some other data, you want it to be less than 5 characters, then you can always say that, okay, less than 5 characters and so on. Okay. But for now, text length equal to 10, I'm going to specify this and I'm going to say okay. Okay. Now what happens is, let's say I put only 5 here and press enter. It will show me an error message, and the error message is this value doesn't match the data validation restrictions defined for this cell. Okay. So for the cell, some restriction has been defined the way we defined it. And because of that, it's not allowing 2 characters. Okay, so similarly, if I put, let's say, more than 10 characters and I press enter, it will give me the same error text. Okay. But when I put 10 characters, so let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and I press enter, then it accepts because it has 10 characters. All right. So this is how you can use data validation. Now you can also define what error message or input message you want to highlight. For example, let's say input message is basically something that people see before they enter the data. So now input message can be, please enter only 10 digits without country code. Okay. And this message, we can also put the same message as error alert. I'm going to put it under error message and I'm going to say okay. So what you see is now whenever I'm trying to enter anything in this cell, it shows me a highlighted message, and the message is please enter only 10 digits without country code. Okay. And of course the data validation will continue. So if I write 345, it will not accept. It will give me the error message, which I just defined, that please enter only 10 digits without country code. All right. So this is how you can use mobile numbers to bring about standardization. And you can always define the list and everything. So let's say, you are sending this to people to fill their data, and you don't want people to put their age as whatever, 24 years, 30 years and 2 months and so on. What you can do is you can select this data, you can go to data validation, and here you can, under settings, put allow this particular data to be only whole numbers. Okay, and you can also specify whole numbers between what. So what is the minimum? Let's say minimum 10 and maximum 100, for example. So if you try to enter anything else, then it will not work. So if I put 123, it will give me error message. Okay, so this is how it's essentially to bring about standardization, because the more standard or clear data that you have, the easier it is for a user to work with that. Okay. Now, if you just want to clear the validation circles, you can select the cells where you had put those validation circles and just say clear validation circles. Okay, so now it's done basically. So now you can just go here, and under this you can put any value and ignore, and that's it. You're done with that. Okay. So this is how you can use data validation. And as I said, the primary purpose of this would be to make sure that user puts in only the values that you want them to put. So let's say if you wanted people to select their subjects, you can do that by putting data validation. Okay. So I'll just show you one more use of this. So let's say again, I'm going to use the same subject here. And here I'm going to put data validation. Okay. But I'm going to use science, English, and mathematics. Okay, so these three values possible. So I'll select this range here. I'll go to data validation. Okay, now in data validation, I'm going to say list. Okay, when I specify list, I get option ignore blank, in cell, drop down, and so on. And the source of the list is going to be science, English, mathematics. All right. Now I select OK. What you see is whenever I go here, I get a drop down, and this drop down says science, English, or mathematics. So you're upfront giving user choices to select. So whether it is this or this, but the user can't put anything else basically, right? So this is how you can also create a drop down. Let's say for age also, if you wanted to create a drop down, you could have given a list of, let's say, whatever, 1 to 30 age group. And then whenever you want to put, whenever a user wants to put his or her age, the drop down will show 1 to 30 numbers. Okay, so this is how data validation can be used. All right, I'm just going to remove this for now. Okay, I hope it's clear. It's not very difficult. So you can try it. If you have an Excel sheet, you can just put some random data and create data validation and then see how it will work. Okay. Now, the next thing that we're going to see is graphs, again, which is a very small topic. You don't have a lot of things in graph, but because Excel 2016, as I said, is something that makes your life very easy. Whenever you select any range, it automatically shows you what you can do with it. For example, if I just select this score, the entire range, when I select this, I get this option at the end. Okay, it's quick analysis. When I click on this, it shows me what is it that I want to do with that. So whether I want to change formatting by putting data bus, or by changing colors by using icon sets, using some greater top 10%, so conditional formatting rules, or I want to put a chart. So when I click on chart, it will show me what kind of chart I can use. So if should I use a clustered chart, or this one, or this, or this. So I can select what I want to do. Okay, so if I just wanted to plot their scores, I can simply select this and I'll get a graph on that. Okay. Now within graph, of course, you have a lot of options. So whenever you get a graph, you have this extra thing that gets highlighted here. So here you can design and format the graph. So whatever the cosmetic changes that are there, you can change colors and so on. Here you can switch row and column. You can specify the range that you want to select. There are a few changes that you can do from here as well. So if you click on plus, you get axis titles, data labels, error bars, legend, trend line. What is it that you want to do? So it's very straightforward. It's in your face that, okay, is this what you want to do? Okay, so you don't really have to search for options. You can change the chart type and everything. You can change how it's going to appear. You can also put in filters if you want any. Okay, just delete this graph for now. Let's say we select this data. Again, I click on this. Under charts, we saw that this is what you can do. If you want some other chart type, you can always select more. You can go to totals. So here you can see it here happening in this particular cell, which is E20. You will see average, sum, count, percentage total, running average, and so on. If you want to convert that into table or a pivot table, this is how things will appear. So this preview option is brilliant. Using this option, you'll be able to just visualize what you want to do and then select what is it. Spark lines we've already seen. So within the cell, it will put spark lines. Okay, so column, line, whatever you want. Okay. Now let's say if you don't want to do that and you want to manually put a chart, you can always go to insert. In insert, you will have recommended charts or random charts. Now there are different types, so 2D column, 3D column, 2D bar, 3D bar. What is it that you want to do? So pie chart. Now let's say you just specify a normal 2D chart. Here they will ask you to select data. So you can click on select data and give this as the range and say OK. And there you have the graph ready for you. Or you can always select the range first and then see what the best graph would be for that particular data. Okay. Let's try putting some other graph. So let's say age this time. I'm just selecting this and I go to insert. Recommended charts is basically Excel predicting what is it that you want to show. So this is how the graphs can appear. So let's say I select this one. So a Pareto chart, or this one, a scatter chart, a line chart, depending on what is it that I want to do. Okay. You can always change the scale and everything. So primary axis, secondary axis, depending on what data you have. So if I want to just change this, I can always click on this, and under format axis, I'll get various options. So the options will be setting the minimum and the maximum bound, defining units, whether it is minimum as minor as 1 unit, major as 5 units. Again, I can change colors and everything through the formatting options that I get. Okay? So here you have axis options, chart area, chart title. So everything will come. So it depends on what you want to do, basically. So there are different things that you can do. Whether you want to highlight it using a chart or a table is good enough to do what you want to do, that completely depends. But as a visual tool, chart is always better. Okay. You can always change chart type simply by clicking on this, and you will get all the possible options that are there. So whether you want to show it as a radar or a stock or a bar, line, anything that you want to do. Okay. Now, if there are two different series, for example, let's say if you decide to plot both score and age, you can select that whole thing, go to insert, click on recommended charts. So it will show you, okay, what is a recommended chart. So whether it is a scatter, or it is a clustered column, or it is a clustered bar chart, or just the normal line graph that you have. Okay. You can always change the size and everything. So those are pretty straightforward things. You can switch row and columns. Again, that will look very weird for this, but you have all these options. Okay, changing chart type again will be very easy. So for example, this which shows the area. So this is the area under this bar and this particular data point, and this is the area under these data points. Okay. So, and of course, the chart styles and everything, you have so many options now. Basically, there's no limit. But whenever you're presenting this, let's say on a presentation or to a client or to your B school professor or anybody, it's always better to stick to a particular color scheme. So if you're making a presentation and if you're using red and blue and green colors, make sure that the entire PPT has red, green, and blue colors. Okay, so don't keep on changing between formats. So if I use, let's say, this particular style, make sure that another graph that you make also has a similar style. It's not very different from the one that you have used. Okay. So this is regarding graphs. I won't be getting into the individual types because that is something that will completely depend on the data. So for this data, pie chart might not really make sense. So pie chart will make sense where you have, let's say, somewhere around 6 to 10 different pies. You want to highlight maybe market share or share of volume and so on. Okay. The next thing, which is the final thing that we are going to be doing, is data analysis. And data analysis is something that you'll be using extensively, especially if you are somebody who is into data analysis, or you are maybe a B school student and you have some assignments from statistics and so on. Okay. So I'll not be getting into the exact the explanation or the concepts of statistics because that will demand a separate session altogether. But I'll show you what you can do with Excel, because of course there are various statistical tools specialized for this purpose. For example, you have SPSS, you have R that you can use, but we'll look at what you can do with Excel. Okay? So the first thing that we're going to do is you need a tool pack for this. Okay, now I'll tell you where you can find it. When you go to File, under File, you have options. When you click on options, you get this window, and in this you have something called add-ins. Okay, now click on add-ins, and when you click on add-ins, you have Excel add-ins. Okay, so just click on Go, and here you have Analysis Toolpack. You know, Analysis Toolpack, VBA, Euro Currency Tool, Solver add-in. So we'll be just looking at the Analysis Toolpack now. I'll click on this, and I say OK. So whenever you select this and you go to data, you will have an additional thing here. If you don't have data analysis toolpack installed on your Excel, you will not find it. Okay, simply because I have done it, I can see an additional header here, which is analysis and data analysis. Now, under this, you have some of the statistical tools that are frequently used. Okay, so you have ANOVA, single factor, two factor, correlation, covariance, descriptive statistics, F-test, Fourier analysis, histogram, moving average. All these things are available to you. Rank and percentile, regression, sampling, t-test, z-test. We'll be doing a few things out of this. Of course, to do this, you need some statistical understanding as well. So if you are practicing something, it's always better that you read about it and then only do it. Okay. Otherwise, the interpretation is going to be wrong. So let's look at the first thing that we'll see is correlation. Okay. Now, correlation in very simple terms is basically movement. Okay. So if one quantity moves up, the other also moves up, then we can say that, okay, there is some correlation between them. Now, this is positive correlation. One is moving upwards, the other is also moving upwards. Now, if one thing goes up and the other thing goes down, then it will be negative correlation. Okay, so your correlation can be positive, where both are moving in the same direction, or it will be negative. So one goes up, the other goes down, and vice versa. Okay, now again, in correlation, it is strong correlation and weak correlation. Okay, so we'll see that. For that, I'm just going to use some random data. Okay, or we can use even score and age. Let's see if there's any correlation between that. So I'm going to select correlation under data analysis. I'll say OK. It asks me what is the input range, what are you grouping by, labels in first row, and so on. So my input range is going to be this whole thing, grouped by columns, labels in first row, and I say OK. Now it will open a fresh sheet because I had selected that, and in this sheet I can see that, I'll just zoom this, I'll see minus 0.11185. Okay, so this is the correlation coefficient between them, minus 0.11185 and so on. The actual value is this, what you can see in the formula bar. Okay. Now I can get this using a formula as well. So I'll show you how you can use formula instead of the data analysis toolpack to achieve this. You can simply write is equal to CORREL, which stands for correlation. Open this and specify the arrays. Okay, so array 1 is going to be this array, and array 2 is going to be this array. And I just close this. You will observe the value that we got here, which was minus 0.1185. That's the same value that you get using the formula as well. So whether to use data analysis toolpack to do this or simply write the formula and get it, that depends on you. So completely depends on your preference. Okay. If you want to just know more about the concept behind correlation or any of the things that we're going to be doing, the best thing would be to go through the Wikipedia article, or you can just search for that term in Google and then see what it means. Okay. So this was correlation. The next thing that we'll look at is covariance. So if you just want to find the covariance, again, input range will be this, grouped by columns, labels in first row. Okay. What you see is you get this as the covariance. Okay. Now this covariance you can also get using a formula. Okay. So I'm going to, this we had calculated correlation. We can also calculate covariance. Okay. Now covariance is equal to COVAR, and covariance again, it's .P.S. So .P is if you have the entire population, .S if it is sample. Okay, so I'm going to select .P. This is the array 1. This is the array 2. Okay, and you see we get minus 4.91, and here also we are getting the same value using the data analysis toolpack. Okay. The next thing that we'll see under data analysis is descriptive statistics, and this is very straightforward, very easy thing to use. If you have large data set, you don't really want to sit and write, okay, what is the mean, what is the median, what is the mode, what is range, what is highest, what is lowest. So all these things you can quickly get by using descriptive statistics. Okay, so let's select this range. I'm going to say data analysis, and you need not select the range in beginning because you can specify it later as well. But I'm going to check for scores. Okay, so data analysis, descriptive statistics. I say OK, and input range is going to be this whole thing. I'll say labels in first row. And here I get some statistical options. So whether you want summary statistics, which I'm going to select, confidence level for mean, kth largest, kth smallest, and so on. We can decide not to select it at this point of time. That's okay. I'm going to say okay. And you get a fresh sheet in which you have all these things ready for you. Okay. So mean, standard error, median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, count. So everything is there right in front of you if you simply use data analysis and descriptive statistics. Now, all these things you can always calculate. So, for example, something like a standard deviation, you can always write is equal to stdev.p.s or just stdev and find that. Okay, so you can just select it and done, right? But this makes your job easier. Okay, so now 15.63 and you have some difference here. So I change this to stdev.s, which is for sample, then I get the same value. So you need to understand whether descriptive statistics is going to be easier because that gives you the whole thing, or you want a specific thing, for example, let's say standard deviation in this case, then and that is for the entire range, then you can possibly just write a formula and then drag it over the range. Okay. So I'll just go back to the descriptive statistics part that you get. You get mean, standard error, median, mode is very straightforward. And there are formula for each of these. So for median, you can write is equal to median, mode, standard deviation, variance, range, minimum, maximum, sum, count. Everything can be done using formula. Okay. Now the next thing that we'll see is under data validation again. I'm going to do histogram. Okay. Now, how do you get histogram? So for histogram, you need to specify bin, and bin is basically the small ranges that you use. Okay, so let's say if you're talking about score, let me define my bin as 60, 70, 80, 90, and 100. Okay, so this is my bin, and as you know, histogram, how it looks. If you select histogram, data analysis, and I'm going to select histogram under this. If I select OK, I get input range. So input range is going to be the score, and the bin range is going to be this bin that we have. Okay. Labels in the first row, I can select whether I want Pareto, cumulative percentage, chart output, and so on. So if I select chart output, for example, and I do OK, in the new sheet, I'll get a histogram. Okay. So 60, 70, 80, 90, 100 and more. Now it's showing 100 as 3. So where is it coming from? I'll just go back to the data. If I put a filter on scores, because our previous bin point is 90, 91, 93, 100. Okay, these are the three values that it is referring to. So when you say 103, it's basically between 90 to 100. Okay. So that is for histogram. Now histogram, you can also construct it using the insert chart function. But data analysis, if you are more comfortable with that, you can always use it. Moving average, random number generation, rank and percentile. Let's look at that as well. So rank and percentile, I'm just going to remove these filters. I hope I can remove this. I hope you guys are following this. Please let me know through the chat window if you have any queries. Okay. But it is largely experimentation. So select data analysis, select what you want to do and see, compare the results. Now let's say you want to look at the percentiles. Okay, so I select data analysis, click on rank and percentile. I select OK. It asks me input range, so I'll select this as the input range. Labels in first row, and I select OK. So on a new sheet, it is showing me the scores. Okay, so these were the scores that we had. Ranks 1 to 18. So this is like sorted now. And then the percentile. So 100 percentile, 94 percentile, 88 percentile, and so on. Okay. Now you can see that the difference between the percentiles is coming to roughly about 6 because there are 18 values and the total is 100. So 100 by 18, approximately you're getting between 5 and 6 as the answer. So that is why your difference between your percentages or percentile, it's going to be around 6%. Now, rank and percentile, we already seen how you can also find rank using formula. You can use the same logic and the total number of people and everything, and then find the percentile as well. Okay, so you can possibly try it on your own. Let me go back to data analysis. Now this time I'm going to do regression, but I'll not be using this table. Okay, I'm going to create a separate table because regression is a different thing. You can't really have only two things and do regression. So for this, I'm going to let's say if you're doing market research, okay, and you are doing a survey, and it's a 7-point scale, 1 to 7. So maybe strongly disagree to strongly agree kind of scale, and you're looking at 5 parameters for a brand. Okay, so you're figuring out, okay, how people prefer a particular brand. Now let's say the parameters that you have are weight, the color of the package, the packaging itself, um, let's say, um, I don't know, the feel of it, maybe how it feels, or let's say appeal instead, let's say cost, and then the overall preference of the brand. Okay, so now overall preference of the brand is something that depends on the weight, the color, the packaging, the appeal, the cost. So these are your input variables. Okay, or what you can call them is, these are independent variables. So it might become a little complex if you haven't done these things before, but don't worry. So basically, independent variable is, there's weight is a standalone variable, color is a standalone variable, but preference is overriding, or it's a dependent variable depending on the other parameters. Okay. Now, what we're going to determine when you say regression is, in regression, you're trying to find uh, which model first of all gives you the best predictor of the preference, or you're also trying to find which one has more impact on the preference. Now you can also use correlation, but there's this, if you Google correlation and causation, you will get to know a lot of interesting things. So two things can be correlated, but that doesn't mean that one thing causes the other. So correlation and causation are very different. So now what we're going to do is, I'm going to just put some random values. I'll be using the rand between function to put values between 1 to 7, because that's the scale that we have defined. Let's say you did a survey and you surveyed, let's say 17 people. Okay, you have surveyed 17 people. These are the responses that they have given. Okay, so for weight, somebody has given 6, color, somebody has given 3. But overall, that person has given preference 5 for that particular brand. Okay, let me just paste this as values. So this is the survey data that you have. Now, dependent variable is preference. All these are independent variables. Okay. So one is, I can find correlation between the independent and the dependent variable. So I can do is equal to CORREL between this, comma, this as the dependent variable. Okay. And I select this. Now remember that I'll have to freeze this because every time it remains the same. I'm going to find correlation of weight with preference here, correlation of color with preference, packaging with preference, appeal with preference, cost with preference. Okay. So now what you're getting is, you're getting a minus or a negative correlation here and here, which means the correlation between color and preference is negative. Between cost and preference is also negative. Okay. But weight, packaging, appeal have certain correlation with preference, but it is very weak because it's 0.01, 0.03 and so on. So if I just copy the entire preference data as it is and put it on packaging, you will see that the correlation becomes 1 because these are the exact same values. But as that is not the case clearly, you will get that, get some other value. Even if you just make this half, for example, if I divide this by 2 and I paste this over this, you will see that I get a perfect correlation because the moment is similar. So the values need not be same, but as long as the movement is in the exact same direction with the same magnitude, you will get correlation value as 1. Okay? But near perfect correlation is always impossible unless the data or the survey is structured in that way, which a lot of people do. I mean, to get favorable results, people will always make sure that correlation attains a certain value, but that's not the best practice out there. Okay, so this is correlation. Now, what we're going to do is we're going to do regression. I won't be getting into the nitty-gritties and the exact details of regression, but I'll show you how you can do it. Now, Excel has a limitation when it comes to regression. So if you're using Excel for regression, you can do up to only 16 variables. But if you're using something like SPSS or R, there's no limit on how many variables you can have. Now, when I say variables, I'm looking at the independent variables. So if you have more than 16 independent variables, you won't be able to do it in Excel. Okay, now let's see how we are going to do this. I'll select data analysis. I'll select regression. Okay, when I select regression and I click on OK, it asks me what is the input y range. Okay, now if you have done even basic algebra uh, or you have done regression maybe before, you know that y is the dependent one because we are writing an equation in the form of x. So variable 1, variable 2, variable 3, all these will have some x component and then that will be equal to y. Okay, so the y is the dependent variable. So I'm going to write this preference, this entire thing, labels in the first row. Input x range is going to be all these independent variables that are there. Okay, so I'll select this, again labels in the first row, new worksheet. If you want any plots, residuals, you can select that. I'm not going to do it right now. And I just select OK. Now, when I select OK, I get all these things. As I said, I'll not be getting into the interpretation of this, but the things that you are largely worried about are these things. So multiple R square, adjusted R square, standard error, and observations. Okay. But of course, when you're looking at the deep statistical analysis, for each of the factors, weight, color, packaging, appeal, and cost, you will get standard error, t-stat, p-value, the lower 95, per 95, and so on. Okay, but all these things are interpretational. But today we are just focusing on the procedure of how to get there. Okay, so I hope you guys go through the theory of regression and try to do it. R is free, so if you're planning to get into data analysis, that is something that you can look at as well in addition to Excel. So learning R is something that you can do. Okay. So in data analysis, as we saw, a lot of things that you can do, but we looked at correlation, covariance, descriptive statistics, histogram, rank and percentile, and regression. Okay. So these are the things that you can possibly do with Excel. Now, of course, over the last 5 days, we have seen a lot of things. We started with very basics. Of course, due to shortage of time, we couldn't get into details of each and everything that is out there. But that is not the point anyway. It's for you to understand, okay, what is possible and how you can experiment with it. Because your learning is going to happen when you actually sit and write formulae. If you're not going to do that, you will always struggle with Excel. Because Excel at the end of the day is a tool which is very logical. But you have to tell Excel what is it that you want. If you can't communicate what you want to do, Excel is not going to help you back. Okay, so make sure that you practice and always ensure that you, if you're let's say using client data or some confidential data, make sure that you have some copy of that before you work with the data. So it's always better to create a sheet and then do it. If you're sending it to somebody, make sure that you if it is confidential, password protected so that the security, because of security concerns. But if you're just practicing randomly, use random values, try to visualize how scenarios might look, and see how Excel is going to help you, because it will make your life easier, definitely. Personally, when I started using Excel, I knew very few things. But over a period of time, gradually, you encounter a situation that, okay, this is something that I want to do, and I can do it manually. But is there a better way of getting there? And that will tell you some shortcut, something that you have never done before, and that will add to your understanding. And over a period of time, you will definitely get better at Excel, possibly reach a level where you can write very complex formulae and do using toolpack, do very good analysis. Okay, so I hope over the 5 days we have been able to touch upon pretty much a lot of things that a normal, average, or even a moderate user will require. But if you have any queries, if you're looking at something very specific, please feel free to get in touch with me. I'll try my best to help you guys. And I'm going to be sharing two files with you. One is on the shortcut, and the other is which is a collection of formulae and the syntax and what those formulae do. So make sure that you go through those documents as well and keep it handy. If you're a student, you can print it and then keep it with you. Or if you are maybe working somewhere, you can print those and put it on your desk, and so that you don't have to search for anything. I hope you guys found this useful. I think over 5 days, we spent roughly about 4 hours doing this, and I had a really good time with you guys. So I hope you also enjoyed and learned a lot. If you have any queries, please get in touch with me. Okay. So this is me signing off for this Excel training program. I wish you all the best with whatever that is that you're planning to do. Okay. So good luck and happy excelling, excelling your life as well as when you're using Excel. Okay. So thanks, guys. Once again, I'll take your leave now. I'll stop recording the session. See you.